Our planet Earth is always on the move. It spins on its axis, creating the cycle of day and night that we experience every 24 hours. But that's not all. We orbit the Sun, a giant star that holds us in its gravitational embrace. This journey around the Sun takes approximately 365 days, giving us the year and the changing seasons. This cosmic dance has been going on for billions of years, a delicate balance that has allowed life to flourish on our planet. But what if we took a detour? What if the path we follow through space was altered, even slightly? What if Earth shifted its position in the vastness of space? Such a change could have profound effects on our world. Imagine Earth moving closer to the Sun, or further away. The distance from our star is crucial for maintaining the temperatures that support life. This change, even a small one, could have enormous consequences. It could alter our climate, disrupt weather patterns, and affect the delicate ecosystems that we depend on. Our planet is finely tuned for life as we know it. The balance of conditions here is unique and incredibly fragile. Temperature, sunlight, and the seasons all depend on our precise position in the solar system. Any deviation could spell disaster or bring about a new era of adaptation. Could Earth really change its orbit? It's highly unlikely. Our planet is held in a delicate balance by the Sun's gravity and the speed at which we travel through space. To move Earth would require an immense amount of energy, something on a cosmic scale. Think of a bowling ball rolling down a lane. It takes a specific force to knock it off its course. Similarly, a massive object like a rogue star passing close to our solar system could disrupt Earth's orbit. But this is a highly improbable event. If Earth were to move closer to the Sun, our climate would change dramatically. The increased proximity would result in higher temperatures globally, affecting every aspect of our environment. Temperatures would rise, potentially causing glaciers to melt at an accelerated rate, sea levels to rise, and coastal areas to flood. This would not only impact human settlements but also disrupt marine ecosystems. Weather patterns would become more extreme. Imagine scorching deserts expanding, encroaching on fertile lands, and making agriculture increasingly difficult. Other regions would experience more frequent and intense storms, leading to devastating floods and landslides. The increased rainfall could also result in soil erosion and loss of arable land. On the other hand, moving further from the Sun would result in a colder Earth. The drop in temperature would have equally severe consequences. We might experience longer winters, shorter growing seasons, and a significant reduction in food production. This would lead to food shortages and increased competition for resources. The expansion of ice sheets would cover more land, reducing the habitable area for both humans and wildlife. This would force many species to migrate or face extinction. Life, as we know it, thrives within a specific temperature range. Our diverse ecosystems, lush vegetation, and vibrant wildlife depend on this delicate balance. Any significant shift could disrupt this balance, leading to a cascade of environmental changes. Protecting our planet's climate is crucial for maintaining the harmony of our natural world. A change in Earth's orbit wouldn't just impact the climate, it would reshape the very geography of our planet. Coastlines would be redrawn as sea levels rise or fall, habitats would shift, forcing animals to migrate or face extinction. Entire ecosystems, delicately balanced over millennia, could be thrown into disarray. Imagine the lush Amazon rainforest transforming into an arid savanna, or the frozen Arctic tundra thawing to reveal a new frontier. These changes would have profound implications for all life on Earth. Life on Earth is remarkably resilient. From the smallest microorganisms to the largest mammals, life has found ways to adapt and thrive in a multitude of environments. Over billions of years, it has survived asteroid impacts, ice ages, and volcanic eruptions. These cataclysmic events have shaped the course of evolution, forcing species to adapt or perish. While a dramatic shift in Earth's orbit would present significant challenges, it would not necessarily spell the end for all life. Some forms of life, particularly extremophiles, might adapt to the new conditions. These organisms thrive in environments that would be lethal to most other forms of life. Perhaps new species would evolve to thrive in the altered environments. Evolution is a powerful force, capable of producing incredible diversity over time. However, this process would take time, potentially millions of years, and would be fraught with challenges. Many species would likely not survive the transition. The loss of biodiversity could be immense, with countless species unable to adapt quickly enough. The future of life on Earth, including our own, would depend on our ability to adapt to a dramatically different planet. Human ingenuity and resilience would be put to the ultimate test, as we strive to find ways to survive and thrive in a world that has changed beyond recognition. In this chapter, we will explore the potential changes in Earth's biodiversity if its position in the solar system were altered. How would different species adapt to new climates and environments? Imagine a world where the once familiar seasons no longer exist, where regions that were once lush and green become arid deserts, and icy tundras transform into temperate zones. In the face of such drastic changes, the adaptability of Earth's species would be put to the ultimate test. Some plants might develop thicker leaves to retain moisture in drier climates, while others could evolve deeper root systems to access underground water sources. Animals might undergo significant changes as well. For instance, animals in colder regions might develop thicker fur or specialized fat layers to cope with new, colder temperatures. Conversely, species in warming areas could evolve to become more heat-resistant. Marine life would not be immune to these changes. Ocean currents could shift, altering the distribution of nutrients and affecting entire marine ecosystems. Some fish might adapt to new water temperatures, while others could migrate to more suitable habitats. The interconnectedness of life means that changes in one species can ripple through entire ecosystems. Predators might find their prey scarce, forcing them to adapt their hunting strategies or diets. Pollinators like bees and butterflies could face challenges with changing flowering times in plants, impacting both their survival and the reproduction of numerous plant species. However, not all species would be able to adapt quickly enough. Extinction events could occur, leading to a loss of biodiversity. This loss would have profound effects on ecosystem stability and human societies that rely on these ecosystems for resources and services. Ultimately, the story of life on a newly positioned Earth would be one of resilience, innovation, and adaptation. The survivors of this cosmic shift would represent a new chapter in the history of life, showcasing the incredible potential for change and evolution in the face of unprecedented challenges. As Earth adapts to its new position in the solar system, humanity faces the daunting task of ensuring our survival. The technological advancements we develop will play a crucial role in this endeavor. Imagine a world where the seasons are no longer predictable, where traditional farming methods are rendered obsolete, and where the very air we breathe could change. First, let's consider agriculture. In a world where climates are drastically altered, we might need to develop new crops that can withstand extreme temperatures and irregular rainfall. Genetic engineering could be key, allowing us to create plants with enhanced drought resistance or the ability to thrive in nutrient-poor soils. Vertical farming and hydroponics might become the norm, enabling us to grow food in controlled environments, free from the unpredictability of the outdoors. Next, we turn to climate control. Advanced climate control systems could help regulate temperatures in cities and agricultural areas, making them more habitable. These systems might include large-scale geoengineering projects, such as deploying reflective materials in the atmosphere to cool the planet or creating artificial lakes to moderate local climates. Water scarcity would be another critical challenge. Desalination technologies could become essential, turning seawater into fresh water for drinking and irrigation. Innovations in water recycling and conservation would also be necessary to ensure that every drop is used efficiently. Energy demands would undoubtedly increase as we strive to power these new technologies. Renewable energy sources such as solar, wind, and geothermal would need to be expanded and optimized. Additionally, advancements in energy storage and distribution would be crucial to ensure a stable and reliable power supply. Humanity's adaptability would extend beyond technology. We might see the development of new architectural designs that can withstand extreme weather conditions, from heat waves to severe storms. Buildings could be designed to be more energy efficient, using smart materials that regulate temperature and reduce energy consumption. In the face of these changes, our social systems would also need to evolve. Education and training programs would be essential to equip people with the skills needed to thrive in this new world. Collaborative efforts on a global scale would be necessary to share knowledge and resources, ensuring that all of humanity can benefit from these advancements. Ultimately, the story of humanity's survival on a newly positioned Earth would be one of ingenuity, resilience, and collaboration. The challenges we face would be immense, but with determination and innovation, we could create a future where humanity not only survives but thrives in the face of unprecedented change. In the concluding chapter, we reflect on the resilience of life and the adaptability of ecosystems. Despite the challenges, life on Earth has always found a way to thrive. From the harshest deserts to the deepest oceans, organisms have evolved to survive in the most extreme conditions imaginable. Consider the tardigrade, a microscopic creature capable of withstanding radiation, extreme temperatures, and even the vacuum of space. Or the humble cactus, which thrives in arid environments by storing water and reducing evaporation. These examples remind us that life is incredibly adaptable and resourceful. As we face a newly positioned Earth, we can draw inspiration from these resilient forms of life. The natural world teaches us that adaptation is key to survival. By observing and learning from these organisms, we can develop strategies to overcome our own challenges. One crucial lesson is the importance of biodiversity. Diverse ecosystems are more resilient to change because they contain a variety of species, each with its own unique adaptations. Protecting and preserving biodiversity will be essential as we navigate our changing world. Another lesson is the power of cooperation. In nature, symbiotic relationships where different species work together for mutual benefit are common. Similarly, humanity will need to collaborate on a global scale, sharing knowledge and resources to ensure our collective survival. Finally, the resilience of life teaches us the value of innovation. Nature is a master innovator, constantly evolving new solutions to environmental challenges. By fostering creativity and encouraging scientific research, we can develop the technologies and strategies needed to thrive in our new reality. In the end, the story of life on Earth is one of perseverance and adaptability. As we embark on this new chapter, let us carry these lessons with us, confident in our ability to overcome the obstacles ahead. With determination, cooperation, and innovation, we can not only survive but flourish in our transformed world. The future may be uncertain, but if history has taught us anything, it is that life, humanity included, always finds a way.